project BIMOMS is a collaboration between IRD and the National Bank of Thailand. The idea is to look at the mechanisms of biodiversity at different scales, from the lowest scales where microbes are important in the regulation of the carbon and nitrogen cycles, up to the higher level of land use changes, and also integrating intermediate levels such as the level of the vegetation dynamics. BIMOMS has two main objectives. The first objective is to better understand biodiversity mechanisms at different levels and how these different levels interact. We don't want to be reductionist, looking at the lowest level. We don't want to be holistic, at looking only at the global level. We want to look at all these different levels and understand how these different levels, these different scales interact. This is the first main objective. The second main objective is to have concrete output, models, software, to be able to predict how biodiversity will change on the long scale. The main research location of BIMOMS is the Khao Yai National Park, and in particular the Mosingto plot. We have selected this plot because our Thai colleagues have worked there for more than 20 years. They have followed vegetation dynamics there. They have monitored different variables of biodiversity. So we want to build up on this knowledge. They have the knowledge of the forest. They have data. They have collaborated also with other colleagues. And this is our starting point. And currently we are investigating other plots to extend our research and look at this dynamics of biodiversity at larger scales.
Hello, we come from NSTDA and National Biobank of Thailand. We come from different labs. First, Dr. Nisha, she works on bacteria and archaea. Me, Anuttara, I work on forest dynamics, plant and wildlife. Dr. Panyawut work on plant molecular and tissue culture. Dr. Komsik works on fungi and mushroom. From the IRD project, we have a plan to look at the different types of the forest. And from the Mosingto plot, we have old growth forest. And then we also have many types of the succession, forest succession. It means that they are different age of the forest, and then we can look at the biomass, in a different age of the forest. And then we want to see that what the land use change, around the Khao Yai National Park, and then we use the Mosingto plot as a model.
My name is Nidhi Jha. I'm a researcher at National Biobank of Thailand, NASTA, and my research is basically is on using the remote sensing technology, trying to measure the biomass and the carbon content of the forest. And I'm trying to do it for Khao Yai, for the whole Khao Yai, and trying to improve the model so that it can be used at other areas as well. I think we believe that biodiversity and change in biodiversity happens at different scales. So it's not just something at the space level that we can check the biodiversity of trees and everything. It also happened at the microscopic level. So the idea behind this is to see the pattern at different scales and try to connect and interlink the different scales. So because I think with the biodiversity of the microbes, they differ from different forest types. So if the forest is young, they have different kind of microbes, and if the forest is mature, they have different kind of microbes. And similarly, same pattern can be seen with the space. So because different type of the forest or different age group have different type of signature or signals and different type of diversity. So this is something that we want to see at different scales, and we try to link it so that in the future we can try to see at other places where we do not have the samples from the fields, for example.